Good morning to all.
Good morning, sir.
Good morning, sir.
Strength of the class is bad. From what I understand from yesterday's discussion on the WhatsApp group, self-energy of a solid sphere is left over. I have two more problems also to be done with that. But could you tell me before the self and what was the last thing I covered in your batch?
So shall I send you the last page of the notes?
No, that won't do. Tell me.
1 minute.
Sir, you did that questions from 200 puzzling puzzles in physics.
Okay. We dealt with force on a sheet of a cube due to the remaining 5 phases.
Yes, sir.
Yes, sir.
Okay. Fine. In Gauss law, did we calculate charge distribution because of the flux through a spherical surface, writing the unit vector of a sphere, ds into
Yes.
xi plus yj cap plus
Yes,
z
sir. Yeah, yeah.
radius? We have done that.
Yes, sir.
Okay. Basically, listen. Self-energy of a solid non-conducting sphere. Self-energy of a solid non-conducting sphere. I need to accumulate charge. 0 to capital R. Now, in a solid non-conducting sphere, you will keep charge inside the sphere. You will keep charge inside the sphere. Now, when you are accumulating charge like this, let us assume that you have accumulated charge this way. At a distance of x, you have accumulated charge. In a hollow sphere, you will bring in dq amount of charge. dq was an arbitrary small amount. Here, dq cannot be arbitrary small amount. dq should be that quantity of charge which you bring, which will increase the radius from x to dx. dq will be that quantity of charge which can increase the radius from x to dx, maintaining the same density. Maintaining the same density. First of all, how much density do you want to maintain? This is 4 by 3 pi r cube. Total charge is q. 4 by 3 pi r cube. This is the density. Now, when I bring in dq amount of charge, it should not arbitrarily change anything. It should change the radius by dx. So, how much will this already existing charge be? Rho into 4 by 3 pi x cube. This step is clear. The charge inside the sphere of radius x is density into this. I will bring dq amount of charge and I will calculate the work done. I will bring dq amount of charge and I'll calculate the work done. How much will dq be? Rho into 4 pi x square dx. Density should be the same. I cannot bring arbitrary charge dq and then say it does the work. Right? Density should be the same. Till here, is it clear to all?
Yes, sir.
Now, what is the potential of this sphere? 1 by 4 pi epsilon naught q by x is the potential of this sphere on the surface. Work done will be V dq. V is this 1 by 4 pi epsilon naught. Q will be how much? Rho into 4 by 3 pi x cube upon x. This is V. Q I substituted from here. dq I will substitute as rho into 4 pi x square d. Work done in bringing dq charge onto the surface of the sphere. Work done in bringing dq charge onto the surface of the sphere. This work done will be rho square. 4 pi will go by 3 epsilon naught, right? 1 4 pi is left over here. Bring it out. 4 pi. Rho came out. This will become x square integral x to the power 4 dx 0 to r. You're accumulating charge, increasing the radius from 0 to capital R. Rho is q square by 4 by 3 pi r cube whole square. Rho is q square by 4 by 3 pi r cube whole square into 3 epsilon naught and 4 pi in the numerator. R to the power 5 by 5. I integrated this x to the power 5 by 5. Substituted the limits r and 0. Right? Q square 4 pi here, 4 pi square here. So I am left with 4 pi in the denominator. Right? 4 pi in the numerator, 4 pi square in the denominator. Right? I'm left with 4 pi into 5 will be 20 pi epsilon naught. 3 here, 3 square in the denominator. I will have 3 left over which will go to the numerator. 3q square by 20 pi epsilon naught. 3q square by 20 pi epsilon naught. Right? R to the power 5, R to the power 6, I am left with R in the denominator. This will be the work done in increasing the radius from 0 to capital R by accumulating a charge of dq on the surface. This will be the self-energy of a solid, non-conducting sphere. Is it a standard formula? Yes. Am I expected to remember this? Yes. 3q square by 20 pi epsilon naught r.
Sir,
Hmm.
sir, conceptually we can define this as work done in charging a sphere of radius r, right?
Non-conducting. Arranging charge this way, not charging a sphere. Charging a sphere means the charge will reside only on the outer surface. You are arranging charge this way. It's like accumulating a clay mold. A clay mold. You are putting some more, then removing some more, creating a mold. Removing some more, putting in, creating a mold. Slowly you are increasing the radius. Here you are dealing with only electrostatic.
Yes, sir, understood.
डेस्टिनी का भी क्या अजीब खेल होता है. आज सुबह सुबह कल शाम से अपने आप को रिमाइंडर दे रहा हूँ कि आई शुड कैरी पेपर एंड स्क्रू गेज विथ मी टुडे टू द क्लास टू टीच यू पीपल दिस.
आज ऑफलाइन है
सर नसीब
ऑफलाइन हो गया.
You see, sometimes I really start believing in destiny.
सर ये सब
याद
फिर
रख
ठीक है
के
सर.
बैग में रख के याद रख के रात को ही बैग में रखा ताकि
सर
सुबह
अगर
सुबह
आप
हो जाए.
सर
सुबह
लास्ट
सुबह
टाइम
7 बजे you will not have our college faculty coming.
सर
No.
अगर आप कल रात को मेरी बात मानते ना कि 8 बजे लेक्चर चालू करना रहता, आज हम सब बच जाते थे सर. आज हमको सबको
अब
ट्रैवल
वो
करना
भी
नहीं
नहीं
पड़ता.
माना, वो भी नहीं माना क्योंकि that's a huge process for me. Again we'll have to talk to Gautam, Preeti ma'am, keep
पता
everybody
नहीं कहीं नहीं उनको सर, नहीं पता नहीं का.
अरे नहीं, अब they will make a mess out of it, so I thought no new headaches.
Sir, the
But
easiest thing is
if
that
we
you
would
could
have
tell them.
Sir,
decided at
can you
8,
move aside?
if we would have decided at 8, then no doubt today people would have been safe. वो भी destiny का ही खेल. क्या थे?
सर आप उनको ये बोलते ना कि मेरे को थोड़ा एक अर्जेंट काम है, आई नीड टू विजिट देयर एंड देन आई वुड बी 1 आवर लेट, तो ऐसा हम बच जाते थे सर.
आज तक 2006 से मैंने पेस में कभी क्लास को लेट नहीं गया. So even if I say that, they will not be.
सर कुछ चीज पहली बार करनी पड़ती है कभी कभी.
तेरे से तो सीखना पड़ेगा मुझे.
सर मैं आज तक इतने टाइम स्कूल गया, मैं सर कभी जाते वक्त जाके वापस नहीं आया वैसा फट. फर्स्ट टाइम इन माय लाइफ हुआ है.
हालांकि it's not you, it's even me. I also started off.
सर हमारा तो फिर भी ठीक है, हम ऐसे आजू बाजू में रहते हैं. हम लोग के क्लास में एक लड़का है विशाल करके, ही कम्स फ्रॉम पालघर. सुबह बेचारा पालघर से आया है वो.
It's okay.
And I met him on the station and he was like, वो कब से हंस रहा है, वो पक गया सर. सर बट एक्चुअली हुआ क्या, वो ट्रांसफॉर्मर क्या हो कैसे गया वो?
Yeah. No, once before also this happened. Before the COVID. वहाँ that area में there is a problem. But it's once in 3-4 years.
मतलब सर पेस कोविड हो या ना हो, पेस में ऐसे प्रॉब्लम होती रहती है.
नहीं. This is very rare, but once the transformer gives a problem, like whole of the building, they ran for 1 day on a generator. But generator अभी limited capacity ही मिल रहा है. इतना सुबह सुबह generator तुरंत नहीं मिलेगा. 10-11 बजे मिलेगा.
Oh, so it's the building one, not the pace one, right?
No, not. So building का बाहर का they keep digging that area, that अंधेरी station के सामने they keep digging for so many. So एक बार वो transformer touch किया तो if they keep us in advance informed that repair work will go on, Pace generally keeps it a generator ready alternate. So I remember one day 3 years back they ran whole of the building on 2 generators. But इतना सुबह 6:30 बजे generator कहाँ नहीं.
सर वैसे भी पेस में आधी चीज चलती नहीं है, पंखे नहीं चलते, पंखे गायब है, एसी नहीं है, जनरेटर का काम.
कुछ भी इसी तरह तुझे you are being punished.
पिटेगा.
Day in and day out AC चलाते हो आप लोग, जाते वक्त बंद भी नहीं करते हो और पंखे की
सर
कंप्लेंट.
चलना चाहिए एसी.
कुछ भी इतना भी खराब नहीं है यार.
डन सर.
No. Can I get the board?
Yes.
Now the other way is half epsilon naught e square. We should get the same answer, but there is a tricky catch. What is the tricky catch? You have the sphere, right? You have charge distributed uniformly. Now you have field inside and outside. When you took a hollow sphere, you did not take field inside and outside. Now here, du will be half epsilon naught e1 square 4 pi x square dx. Half epsilon naught e2 square 4 pi, I call it small r square dr. Is that part of the board visible?
Yes, sir.
This I will have to integrate to get the total energy stored. This I will take from 0 to capital R. This I will take capital R to infinity. 0 to, why did you split it into two? The field inside and field outside are not the same. Even k cube by inside, k cube by
R bar.
r cube, sorry,
X by R
x
cube.
upon r, right? E2 outside, k cube by r square. Outside, you are taking here an element at a distance of x of thickness dx. Outside, you are taking an element of radius x and dx. Radius x and dx. This is dr. वैसे वर्सा लिया यहाँ r लिया है मैंने r dr. This is x d. Substitute and see if you are getting the same answer of 3q square by 20 pi epsilon naught r. Can I rub the board? Are you people there?
Yes,
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 sir.
sir.
Yes, sir.
Did I solve one problem where in a ring you are asked to find out charge q and displaced in the plane of the ring will perform a section?
Yes, sir.
Yes, sir.
Sir.
Now, two typical structured problems. Firstly, this is an old JE question. Both these questions are old JE. First question asked is, a ball of radius r, carries a positive charge whose volume density is rho is equal to rho naught into 1 minus r by r. Positive charge. There's no negative charge, it's volume. Ball of radius r carries a positive charge whose volume density is this, where rho naught is a positive constant. And because it is non-conducting, I should give you epsilon r. He gave you epsilon r as 1. Find the magnitude of the field. Find magnitude of field at r less than r greater than. 2 bits. Find the magnitude of the field at r less than r greater than. This was those days a subjective paper, not very difficult, but then an old JE question, hence it deserves that respect. I will wait for 2 minutes for you people to solve. You have charge all throughout this ball. Assume a spherical shell of radius x or smaller and thickness dr. First, I should find out charge enclosed inside. What will dq be equal to? Rho into 4 pi r square dr. This is rho naught into 1 minus r by r, 4 pi r square dr. Density in this region. This will be dq. Integrate this from 0 to small r. But do one thing, take this as x and this as dx so that you don't mess up with the symbols. 4 pi x square dx. Least value of x is 0, maximum value of x is r. That means you are finding out the charge enclosed at a distance of small r. This will be the charge enclosed between 0 to small r. This step, did all of you understand?
Yes, sir.
Yes, sir.
Once I know the
Yes,
charge
sir.
enclosed till a radius of small r, closed integral E dot ds. Is this charge enclosed by epsilon naught? E into 4 pi r square is equal to q by epsilon naught. This charge I will substitute here and get the field. Now for outside the sphere, procedure is the same. Only thing, limits will change from 0 to capital R.
R to infinity.
Rene, you are finding out the charge.
हाँ sir.
Charge 0 to capital R. Total charge enclosed. I'll draw the diagram. The way you told me R to infinity, I think you people are in trouble. Solve this. I'll solve for the second bit as well.
Sir.
Hmm.
Sir, can we use the formula inside for field inside a solid sphere and then
Cannot.
integrate?
Density is not constant. That formula is for uniform density. Here density is not constant. That's the reason why we are making you solve this problem. Your answer in this case should be, the field ka answer is rho naught small r by 3 epsilon naught 1 minus small r by capital R. Sorry, 3 small r by 4 capital R. 3 small r by 4 capital. Tell me when you're done with it.
Yes, sir.
So wait. Done, sir.
Now, when you are taking outside, charge will be only up to capital R. When you are taking outside, charge will be only up to capital R. That will not change. Now, this is the total Q. Now take a Gaussian surface like this. Closed integral E dot ds is Q by epsilon naught. This charge should be substituted here. The difference is we have integrated from 0 to capital. Here E integral 4 pi small r square is equal to Q by epsilon naught. E into 4 pi small r square is equal to Q by epsilon naught. Q you will substitute here. This is small r is the radius outside. You gave me in terms of small r. Q will be from 0 to capital R. Outside capital R you will not have charge. This is the second bit.
Sir. Sir.
Hmm.
So in this question, why they are given two variables? Like they are given small r and capital R, but we used x and dx. Can't we use r, dr and then integrate?
They are asking at a distance of small r. तो इनसाइड स्मॉल आर आपको स्मॉल एलिमेंट लेके इंटीग्रेट करना है टोटल चार्ज के स्मॉल एलिमेंट जब ले रहे हो अगर आप भी स्मॉल आर यूज किया
सर तो क्वेश्चन में x नहीं दिया था ना वो डेंसिटी में r ही दिया
they are asking you the field at a distance of small r.
Okay.
Now how do you calculate q from here till here when density is not constant? You will have to consider
Integrate small element. Yes sir.
So इस एलिमेंट का रेडियस भी स्मॉल आर ले लो
नहीं okay.
Hence I took a separate. No, the second question is slightly tricky. Solve it orthodoxly, you will get the answer. Write down the question. A system consists of a ball of radius capital R. This is also an old JE question. A system consists of a ball of radius capital R. A system consists of a ball of radius capital R carrying a spherically symmetric charge capital Q. Carrying a spherically symmetric charge capital Q. Carrying a spherically symmetric charge capital Q. Full stop. The surrounding space is filled. The surrounding space is filled. Surrounding space is filled. Surrounding space is filled with a charge of volume density. Surrounding space is filled with a charge of volume density alpha by R. Magnitude of the electric field. Magnitude of the electric field is independent of smaller. Don't try to visualize this problem, just solve it. This is capital. Outside, you're telling me that the charge is dependent on this. Outside, you're telling me the charge is dependent on this. You're asking me this Q for which the field will be independent of R. You sit and try to visualize this, you will be in big time trouble. Just solve it and the job will be done. That's the irony in this problem. A very tricky old JE question.
Sir, 2 alpha pi r square.
I think is correct. 2 alpha pi r square is correct.
Yes, sir, same answer.
Wonderful. Technically, first of all, closed integral E dot ds is net charge enclosed q plus q by epsilon naught. Q is the solid sphere. Small q is the charge from here till here. Small q is the charge outside because of this density. So this is the charge enclosed inside. He's asking you this charge so that the field is independent of small r. So first to find out small q. First to find out small q. I'll take dq is equal to density into 4 pi r square dr. Capital R to small r. Call this x square dx. Capital R to small r. At a distance of x of thickness dx. Don't keep using the same symbols. Till a distance of small r. Rho is how much? Alpha by x. 4 pi x square dx by x. In this case, I'll take r as x because it depends on the distance from the center. So, alpha by x I put. Integrate from capital R to small r. Capital R to small r. 4 pi alpha. Integral x dx is x square by 2. This will become 2. R square minus capital R square is small. Substitute this small q here. I calculated the charge from capital R to small r. Small r is somewhere here. Capital R to small r. Capital R to small r. So from here till small r, the charge is small. Agreed? Now when I use it in this equation, this small q you substitute here, you will get closed integral E dot ds is capital Q plus 2 pi alpha r square minus r square by epsilon naught. Right? Left hand side is integral E dot ds. E integral ds is 4 pi r square cos 0. Bring that to the denominator. E is equal to, when I rearrange this, bringing this 4 pi, q by 4 pi epsilon naught plus 2 pi alpha by 4 pi epsilon naught r square minus 2 pi alpha by 4 pi epsilon naught capital R square. All I have done is opened up the bracket and brought 4 pi to the denominator. Now you are asking me, this field should be independent of what? Independent of small r,
Smaller.
right? This field should be independent of small r. Did I forget some small r in the denominator?
Yes, sir.
Small r square will come here. Small r square, small r square, small r square. So this will get cancelled out, but I'll have this. Now observe this expression, it doesn't have small r. These both expressions have got small r. If field should be independent of small r, these both should get cancelled out. Do you agree with me?
Yes, sir.
If field should be independent of small r, these both should get cancelled out. When will they get cancelled out? Denominators are the same. When q is equal to 2 pi alpha r square. Now this and this will get cancelled out. It is independent of small r. Once you do the mathematics of it, it's quite simple. But trying to visualize this will not be that easy.
Sir, I did a different
Like,
I calculated field and resubstituted it.
फील्ड कैलकुलेट करके कहाँ पर सब्स्टिट्यूट किया?
मैंने 2 चार्ज नहीं लिया, मैंने एक ही चार्ज लिया और 0 से R इंटीग्रेट किया वही
नहीं
चार्ज
होगा.
को।
This is constant charge. In this sphere, charge capital Q is constant. The variation of this density comes from capital R to outside only, not inside. Ille, not permitted.
Sir, but R is given distance from center of sphere now.
Right. So lower limit will be capital R. Density inside is not alpha by R. He clearly told you density outside is alpha by R. Density inside is constant.
Okay, sir.
Can I rub the board?
Sir, 1 minute.
Thank you, sir.
मैकेनिकल प्रॉपर्टीज ऑफ मैटर, सरफेस टेंशन इंट्रोड्यूस हुआ है आपको?
हाँ सर खत्म हो
Yes, sir.
No, there is one typical problem to be discussed on it. I'll take it in the form of a problem itself instead of explaining the theory. Right. Have a look at it. Surface tension of soap solution, soap bubble. P is the surface tension. This is of radius r. Soap bubble will have two surfaces. Are we aware of it?
4 sigma.
That's why the pressure difference you equate to 4P by R. Right? This is of radius R. Write down this statement. Atmospheric pressure is P naught. P naught is atmospheric pressure. Write down this statement. Find the charge that must be spread uniformly on its surface. Find the charge that must be spread uniformly on the surface. Find the charge that must be spread uniformly on the surface. So that its radius becomes 2r. So that its radius becomes 2r. So that its radius becomes 2r. Will you people try or should I discuss?
So we'll try.
We will try.
One important assumption, assume the temperature is constant. Why did they give that assumption? If the temperature is not constant, surface tension will keep varying. You have to assume the temperature to be constant. Don't forget that.
सर अंडर रूट में आएगा.
Under root में आएगा, right? Originally, what did you people do? Delta P is 4T by R. This is what we did. Agreed? Now here it will be 2 times R. Delta P is 4T by R. Here the new radius is 2R. But electrostatic pressure, this delta P, if I take the pressure here P1 and P2, P1, this pressure difference is trying to push the bubble out. Because pressure on the concave side is always greater than the pressure on the convex side. The surface tension is trying to hold it down. Why should the surface tension try to hold it down? Because this surface appears lesser the surface, lesser the potential energy. Surface tension will try to squeeze in. Pressure difference will try to push it up. Do you agree with that? कुछ तो बोलो.
Yes, sir.
Yes, sir.
Now, electrostatic pressure will try to push this bubble outwards or inwards?
Inward.
Inwards.
Outwards due to repulsion.
सेल्फ एनर्जी कितना पड़ा है यार, इनवर्ड्स कैसा लाएगा यार, ये मेरी समझ के बाहर है. You have positive charge. Didn't we calculate self energy by telling you it expands outwards? Work done will be PdV.
Yes, sir.
Yes, sir.
Yeah, है कि नहीं?
Yes, sir.
Inwards electrostatic pressure for 2 positive charges will come closer. क्या बोल रहे हो तुम लोग? 2 positive charges will repel, it will go outwards. So it adds to sigma square by 2 epsilon naught. Delta P also is pushing the bubble outwards. Electrostatic pressure also is pushing the bubble outwards. What is holding it? Surface tension. Now, delta P, if you get P1 minus P0 is 4T by R, initially pressure. Now, P2 minus P0 is 4T by 2R. Now, the new pressure when it expanded to 2R. How do you relate P1 and P2? Temperature is constant. Temperature is constant. Temperature is constant. So P1 V1 is equal to P2 V2. How many concepts, small things are merged in it there? Surface tension, electrostatic pressure, gas law. P1 V1 of the air trapped inside will be equal to P2 V2 of the air trapped inside. Now you remember, now you understand why categorically I insist on temperature being constant. Right? P2 will be P1 by 8. P2 is P1 by 8. Right?
Yes.
Say something. Now I need P2 minus P0, 4T by 2R. I need to substitute in the place of P2. Right? How much will I get P2 as? P2, observe this, P naught by 8 plus T by 2R, P naught by 8 plus T by 2R. So delta P will be P2 minus P naught. How much will you get? P by 2R minus 7 P naught by 8. This delta P you substitute here and simplify for sigma. Find sigma.
Sir, I have a doubt.
Hmm.
Sir, where did we get 4T by R from?
तो
Surface
आप लोगों ने बोला सरफेस टेंशन हुआ है तो मैंने प्रॉब्लम सॉल्व किया.
T is sigma.
क्या?
No, we take surface tension का that symbol of sigma in our question. So T you told that it is coefficient.
Surface tension. It seems you people use the symbol sigma.
Okay, sir, understood.
This completes electrostatics. We have discussed doubts of electrostatics up to which assignment?
3. Gauss law assignment 1.
Gauss law assignment.
So Gauss law assignment 2 is yet to be discussed. As I understand from your group discussion, you people
Correct.
need some more time for that. Am I right?
नहीं sir हो गया.
हो गया
हो
सर.
गया सर.
Oh, sir.
Can I discuss the doubts of that?
Yes.
Yes, sir.
Yes, sir.
Yesterday in the group, some students were asking me to wait. That's why I kept that pending.
तो रात को कर.
खत्म कर दिया रात को.
रात को हो गया. Okay. Then have 10 minutes of a break. I'll discuss the assignment doubts after the break. 15 minutes of a break, so not an issue.
सर ऑनलाइन में ब्रेक की जरूरत नहीं है.
हाँ सर चलेगा no break.
It's okay. Now we have the luxury of it having completed the syllabus.
अरे चाय पी के हो गया मेरा.
आपका हो गया. मेरा भी कभी कभी ख्याल रखो.
मेरे को लगा सर आप क्लास में 9 बजे पी लिया रहेगा आपने.
No issue. Take a 10 minutes of a break. Host will remain connected. Co-host will disconnect. Right? I will discuss the assignment doubts of this.
Sir, in this question, can you explain the first line you wrote? I have forgot that. This. Why delta P and
Delta P, P1 is greater than P0. Are you aware of it? Pressure on the concave side is greater than the pressure on the
yes.
So the excess pressure will tend to push the bubble outwards. Surface tension will try to shrink the bubble.
Okay, got it.
Electrostatic pressure also acts.
Okay.
So you'll discuss just the Gauss law assignment too, or you'll take booklet also?
Sir,
What
HCV
would
and
you people prefer?
sir, HCV and Gauss law assignment.
HCV not
Booklet
done.
also.
So booklet we
Exercise
need
one
to
booklet.
नहीं एक ही होगा इतने सारे नहीं
Gauss law assignment.
Yes, assignment.
Assignments.
fine.
Assignment and HCV.
assignment. First we'll complete assignment and then we'll discuss HCV. HCV जल्दी हो जाए.
हाँ
हाँ,
सर
sir,
चलेगा,
HCV.
छोटा ही है.
हाँ छोटा ही. Are you people back?
Yes.
Yes, sir.
Gauss law assignment. Tell me your doubts.
4. The 4.
6th.
16 and 17.
So third can't meet on.
So 14th question, third part.
14.
Third part.
Third question, second bit.
Sir, can you do all of the third question? Sir, 15th third part.
Now, third, two conducting thin spherical shells are joined by a conducting wire and cut after some time. When charge stops flowing, right? Find out the charge on each sphere R. After that, also find the heat produced in this process. First of all, one second. Third question. Right. Wait second, रुको. The help of the wrong. Starts from fine. What was the initial charge given to this? Qn minus 32. Am I dealing with the correct question in the assignment sheet?
Yes,
that I have
sir.
got? It's the non-rectified one. So problem numbers don't match. This is to R and R. Right? After you have connected the shell, after connecting the shell, final charge on the inner shell will be 0. Whole of this charge will come out. Right? So this will be minus 2q. Do you agree with that? Whenever you are connecting the inner shell, Van de Graaff generator, inner shell, outer shell, whole of the charge from the inner side will go to the outer side. Do you agree with that?
Yes, sir.
Or do you want me to calculate and show you that whole of this charge will come to the outer shell, which we have already done? Tell me, is this clear or not?
Sir, can you calculate?
What will be the potential of the inner shell? K Q by, once you are connected, K Q by, this is QA, this is QB. This is RA, this is RB. What will delta be equal to? VA minus VB. What is VA because of both the spheres? KQA by RA plus KQB by RB minus of KQA by RB plus KQB by R. This is actually not fair. We dealt with this in detail in the class. Van de Graaff generator. These both will get cancelled. This will be KQA into 1 by RA minus 1 by R. Now when you connect both, delta V should become 0. That means QA should become 0. That means whole of this will go to the outer surface. Sphere, holding, hair raising, both work here. Another way of looking at it in shielding also we explained that if this is connected, you cannot give charge to the inner side. It will come to the outer side by default. Everybody clear about this?
Yes, sir.
Yes.
Thank you.
This is forgotten, whole of shielding has been lost. Right? You cannot afford to forget this. The most important thing in shielding this is you cannot
What about-
give charge to the inner side of the sphere without keeping charge inside the cavity. Whenever you give charge to the inner side and connect to the outer sphere, charge will come to. एक वीडियो भी दिखाया था यार मैंने आपको कंस्ट्रक्शन ऑफ वैन डी ग्राफ जनरेटर वीडियो दिखाया कि नहीं?
हाँ सर देखा है।
हाँ, sir.
Yes, sir.
Whole of this charge will come to the outer side. This will be 0 and minus 2. Now heat produced is equal to loss in potential energy. Loss in potential energy. That means U initial minus U final. U initial, how do you want me to calculate? I'll tell you how to calculate, you will do the calculation. Self energy of this, interacting potential energy between the two. Self energy of this, KQ square by R, Q square by 8 pi epsilon naught R minus 3Q whole square by 8 pi epsilon naught 2R. Interacting potential energy between the two, 1 by 4 pi epsilon naught minus 3Q by 2R into Q. This is the initial potential energy. What will be the final potential energy? Minus 2Q whole square by 8 pi epsilon naught 2R. Difference is the heat loss or heat produced. Tell me when I can rub the board.
Done
Sir,
sir।
you can rub the board.
Four. There are three concentric metallic thin shells of radius R, 2R, 3R and charge Q minus 2Q. So we find the charge on each spherical shell after joining the innermost shell, outermost shell by conducting wire. Once again, not fair. I have a feeling I have
Sir,
done it.
outermost answer is not matching.
Yes, sir.
Yes.
Okay, let us solve it.
Yes.
Q minus 2Q and how much is given? 5Q. What did he ask? Find charge on each spherical shell after joining the innermost. I take this to be X minus X. So this will be X minus 2Q. This will be 2Q minus X and this will be Y. Am I right? So X plus 2q minus x plus y is equal to 6q. Initial charge on both of them put together. Y is equal to 4. Y is equal to 4. Now, due to all of them, potential on the inner shell should be equal to the potential on the outer shell. Potential on the outer shell calculating is quite easy. Why? Because x and minus x will cancel out everywhere outside. These both will cancel out everywhere outside. So I am left with only this. So this will be k 4q by, what is the radius? 3r. K 4q by 3r will be equal to, due to all of them, potential on the inner shell will be kx by r, k minus x by 2r, kx minus 2q by 2r, k 2q minus x by 3r, plus k 4q by 3r. This will get cancelled. I am left with k and r will get cancelled out. This is x. This is minus 2 and 2 will go. Q by r minus q by r. R also gets cancelled. Minus q. R all throughout got cancelled. R, k, x. This x is equal to, maybe it's on the same side. This is 0 equal to, I will have, where am I? X minus q. Now here, 2q by 3. 2q by 3 plus 2q by 3 minus x.
Sir, x by 3,
By 3.
right?
X by 3.
Minus x by 3. Right? So now it becomes 0 equal to 2x by 3 minus q by 3. X is equal to q by 2. Is my calculation correct?
Yes, sir.
Now you have a problem with the charge on the outermost sphere. वही तो बोल रहे थे 2q minus x is q by 2. 4 minus 1 5q by 2. And this is 4q plus of 4q. This will be 8 plus 5 is how much? 13q by 2. Initially it was 5q. Now it is 13q by 2. What is the answer given?
5q by 2.
Answer given 5q by 2. Why? Did we do that? Did we go wrong with the calculation? Did you people also get 13q by 2?
So we got 11q by 2.
Yes, sir.
Where did I go?
Sir, your 2q minus q by 2. 3q by 2 it should be.
Oh, my bad. 2q minus x is q by 2. 4 minus 1. 3q by 2. 8 plus
Yes,
3.
11Q by 2.
11q by 2. So 11q by 2 will be correct. Or did they calculate just the surface on the outer surface? Outer surface is 4q. Inner surface is 3q by 2. Either way, we will not get 5q by 2. Either way, we will not get 5q. It is 11q by 2. I'll change the key. See, it's quite logical that it should be 11q by 2. Listen, you calculated x as how much? Q by 2. X how much did you get?
Q by
By
2.
2.
Out of q, I am left with q by 2. So q by 2 should have gone out.
Yes, sir.
Yes.
Outer sphere, you have got 5q. You are adding q by 2. How
11
much
cube.
will that be? 11q.
11.
Very simple straight hit, right? Can I rub the board?
Yes, sir.
Yes, sir.
1 minute.
Yes, sir.
Done.
No, next question. What did you people say? Sixth question, right? A neutral conductor as a cavity as shown. A point charge Q is kept inside a cavity. Uniform electric field exists in the space. You have a point charge. This is a cavity, right? And you have an electric field in the space. So you will have Q induced on it. You will have minus Q on this. Plus Q will go out, which will not be uniform. Net force acting on Q. Is this what they asked? 1 second. Am I reading the right question?
Yes.
Yes, sir.
9. Here in this, it is the 9th question. Confusion. Right now, have a look at it. If this were spherical and if it were uniform, then I would have told you the all external will give me 0. In that aspect, I have no problem. Right? All external charges, this electric field, Q induced, everything put together, the force on it is 0. Anybody with a doubt in it? Say something.
No, sir.
No,
Sir.
Now, my only trouble is minus Q, and this is not spherical in distribution. This is not spherical means field because of minus Q inside is 0 is a myth. I cannot say anything about it. So force because of minus Q on Q, I cannot say. Hence, net force on Q inside, I will not be able to answer that. Net force acting on Q. What is the answer given? Cannot find.
Yes, sir.
Yes.
Now, second question asked is net force acting on the conductor. Net force acting on the conductor. We have a small issue for that. Listen, there is a good catch in this. Minus Q came in. Outside, why don't you write plus Q? Net charge will be plus Q only. Right? Now, plus Q, is it uniformly distributed? No, because plus Q should be cancelling out this field also inside. If this were spherical conductor, just imagine the same thing if it would have been spherical. Maybe I would have made a guess, but bottom line, this plus Q will not appear to be concentrated here in this particular shape of the conductor. Do you get this point?
Yes, sir.
Yes,
This
sir.
question is force on the conductor. So neither is that uniform, and I don't know how this arrangement is. This arrangement will be negative charge this way and positive charge here this way. 1 second, wait. Due to this electric field, force on this will be 0, the induced charge. Due to this electric field, force on the induced charge will be 0. Because whatever may be the charge distribution, net charge of this will be only Q, negative and positive. P-bed, I think I'll have to make the correction. Force on the conductor due to this must be minus Q. It may not be uniformly distributed. But yet, Q and minus Q will give me 0 here. Do you agree with that?
Yes, sir.
Electric field will give me 0 on this. What did he mean by this net force acting on the conductor? 1 second, wait. Electric field E exists in space, then net force acting on the conductor. Net force acting on the conductor. Q and minus Q will give me 0 here. Q and minus Q everywhere outside will give me a field of 0.
Yes, sir.
No, there is a small issue. Force on minus Q due to Q, I don't know. Force on minus Q due to Q, I don't know. Outside they may cancel. Minus Q is not uniformly distributed. Force on minus Q due to Q. All external put together will give me 0 force on this. But force on minus Q due to Q, I don't know. Are you people getting this point? If it were spherical, then what would I say? Minus Q will give me 0 force on Q because it is uniform.
Yes, sir.
Yes, sir.
Vice versa will be true. Force on minus Q due to Q will be 0. Action and reaction. Force on minus Q due to Q in this case is 0, not in this case. Minus Q due to Q cannot say. But force on plus Q due to field, force on plus Q due to field is 0. See if you are convinced about this. See, why this plus Q? There will be some like this, some like this. Some negative charge might have come, positive charge might have come. But all put together, net charge on the outer surface will be only Q and field is uniform. When field is uniform, you keep minus Q here, plus Q here, net total charge when you keep as originally the sphere was neutral. So net total force on conductor due to the electric field. This minus Q and plus Q put together will become 0. Force on conductor due to electric field, minus Q and plus Q. Wherever you keep minus Q plus Q. On this also minus, on this also plus, QE will turn out to be 0. This step is everybody clear?
Yes.
Sir.
Now in the previous case, why are you telling me cannot say? Because force on the conductor may, force on minus Q due to this Q, I am not in a position to speak because this is not uniform. But if it were spherical, I will confidently tell you force on Q due to minus Q is 0 and the vice versa will be 0. Newton's third law. But in this case, I cannot say. Then the third bit you are telling me is 0. Why? Because E into Q into minus Q will be 0.
Sir, just because it is non-uniform, we cannot say if instead of a sphere, say we were given a cuboidal cavity, then still we could say now the force on minus Q due to.
Cuboidal cavity with uniform distribution, yes, by symmetry.
Yes, sir.
Sir, can you explain?
One second. हाँ बोलो फिर से बोलो.
सर ए बिट आप फिर से बता सकते हो? मैं आप cannot find क्यों?
A bit is force on Q. Because of minus Q, I don't know. It is non-uniform.
Okay.
Right? Now, what is the next bit asked? I am unable to see the print clearly. Fourth bit.
Net force on the induced charges on the outer surface of the conductor.
Oh, that will be quite easy because these both charges put together will give me zero field here. All internal charges put together will give me zero. Only this field is there. E into plus Q.
Yes.
E into plus Q. Fourth bit is D bit is E into plus Q. These both together will give me zero here. Only this field into plus Q, and that field is uniform. Last bit is net force on the induced charges on the inner surface of the cavity. I am at square one. Due to this Q, I am unable to find out the force on minus Q. That's what we have been explaining even for the B bit. Because of this Q on minus Q, I don't know the force. Yes or no?
Yes, sir.
Yes, sir.
Yes, sir.
Ununiformly distributed.
Yeah, the non-uniformity के वजह से on this I don't know the force due to this. On this due to all external fields is zero. E and plus Q together will give me zero here. But because of this Q, I am unable to find out the force on minus. Is that clear?
Yes.
Tell me when I can rub the board.
Sir, initially in the conductor, negative charges, how did you get? So the negative charges will come close to.
Plus Q is the net charge. Plus Q is the net charge of the outer surface. But that will redistribute because of this field. Because this and this put together should give me zero.
Okay.
This should give me a field in the opposite direction. So positive charge will spread the side. Some negative charge from the metal will come, some positive charge will come to the right. But net charge of the outer surface is plus.
Okay.
Sir, the force on Q inside the cavity by the field and the plus Q on the outer surface will be zero.
Zero.
Okay.
Tell me when I can rub the board. Can I rub the board?
Yes, sir.
Now the next question you said, 14th third bit. Tell me if I am drawing the question correctly. Some weird shape of the cavity. This distance is small r. This distance is capital R. Did I pick up the right question? This is A
Yes, sir.
and this is B. You have a charge Q. This is center is C. Radius is capital R. Right? Q is given where? At this particular point. Did I pick up the right question?
Yes, sir.
A neutral conductor of radius capital R and an irregular shaped cavity has a point charge Q kept at a distance of R from its center. Find the electric field and potential at points A, B, and C for each case. Right? Field and potential at A. See, if I have got Q here, I will have minus Q on the inner side plus Q on this side. But field at A will be 0.
Yes, sir.
Right? Potential at A. Because of Q and minus Q will cancel out here. Because of Q, I will have KQ by capital. Say something. Are you convinced?
Yes, sir.
Yes.
Right? Field at B, you will have to give me this distance. Q and minus Q will cancel out at B. Do you agree with that?
Yes, sir.
Ha, sir.
Q and minus Q will cancel out. Only because of this Q, I will get KQ by CB. Give me the distance between CB. I'll tell you the field at B. Now, potential at B, also the same thing. These both will cancel out here. It will be KQ by CB. As simple as that.
Yes, sir.
Are you able to hear me?
Yes, sir.
14.
Sir, point C is left.
What is the point C? Where is point C?
Center.
Center.
Oh, yeah. Point C.
E is cannot.
See, this is irregular. So minus Q के वजह से I cannot tell you the field at C. I can tell you field at C only because of Q. Field at C. My answer will be cannot say.
Yes, sir.
Same. Minus Q is the disturbance maker here. Minus Q is the spoiler rather. Because of Q, I can tell you both field and potential at C. Because of capital Q, I can tell you at C. But minus Q is my spoiler. If it were uniform charge distribution or a sphere, hollow sphere, then because of minus Q, field here will be 0. Potential will be K minus Q by that radius. Non-uniform distribution के वजह से I am neither able to tell you the potential nor field at point C. Tell me when I can rub the board.
Sir, so can we generalize that for a non-uniform body, it is always the internal induced negative charge?
Please see every situation separately. Don't generalize. उसमें कोई फायदा नहीं है. नुकसान ही होगा जल्दबाजी. Please see, these are well laid traps. Right? Every situation independently देख लो. He can create any number of situations.
Okay, sir.
Fifteen. 15th में is it the question a spherical conductor of arbitrary shape and also an arbitrary cavity. has charge Q here. Right? Has a charge of capital Q. Spherical conductor has a charge of capital Q. Conductor has a charge of capital. Point charge Q is kept at the center of the conductor, and another charge Q naught is kept outside the conductor at point P. At point P, you have kept Q naught. This is smaller. Right? Now you have a point B here, OB. This is OA. This is OP. Fine. Find the, what did you people say? 15th third way. Electric field at point A, B, and C due to induced charges on the outer surface of the conductor. I will have some induced charges here. A, B, and where is C? C is an
Outside.
arbitrary point here. This is C. Am I right?
Yes, sir.
Let me see this. Field at point A. Right. Field at point A. Now listen, I will have Q induced on the inner side. What did he ask? Electric field induced charges on the outer surface of the sphere. Induced charges on the inner and outer surface of the conductor. Find induced charges on the inner and outer surface of the conductor. Electric field at point A, B, C due to induced charges on the inner surface of the cavity. Right? Electric field at A, B, C due to induced charges on the outer surface of the conductor. Right? Have a look at it. You have Q naught. You have Q induced on the outer surface. Net total, I will take Q induced. Right? Now, this net total Q induced plus Q naught should give me 0.
Zero.
Here. Listen
Yes,
to me
sir.
carefully. 1 second. Are you able to hear me?
Yes, sir.
Amazon is will be coming up. Listen, all external charges put together will give me 0. If this distance is what? PA, if it is given, field because of this and field because of the induced charge will be equal and opposite at it. Is it clear? Field because of induced charge, how will I tell you? Because of Q naught. KQ naught by PA whole square is the field because of net induced charge on the outer surface. Total charge on the outer surface, I will call it Q induced. Q induced. You are given some charge to it, right? That capital Q, Q induced, everything put together, you are calling it Q induced on the outer surface. Right? This plus Q induced put together should give me 0 here. Do you agree with that?
Sir, because
sir.
we directly cannot calculate field due to Q induced, we are using it concept.
Right? We have done this previously.
Yes, sir.
Now same applies to B. Give me PB, I tell you. Q induced and Q naught put together will give me 0 here. Yes or no?
Yes, sir.
At C, I am in no position to calculate. Because unless you tell me this is a sphere, tell me sphere, I can tell you Q induced. Now because of Q naught and Q, it will not cancel out here. Q naught is helpless. इसके वजह से यहाँ field will be, whole of this will appear to be concentrated here only if it is spherical. If it is not spherical, I cannot say.
Yes. Sir, in the first case, can you, like at point A, can you tell the direction of the field?
This will give me a field this way. All of the induced charge will give me a field in the opposite direction. PA का यूनिट वेक्टर अगर ले लोगे माइनस PA का डायरेक्शन में फील्ड ड्यू टू इंड्यूस्ड.
Okay, sir. Thank you. Done, sir.
I should see what is this. Let me track the 16th question one second. So, cube over fine. Fine. Okay. 16th May, this is the sphere and this is a cavity cut out this way. Did I pick up the correct question?
Yes, sir.
An uncharged spherical conductor of radius r. Radius is given as r. Has a cubical shaped cavity as shown. There is a point charge Q outside the conductor at point P. Point charge Q at point P. No, there is a point A here. Right? Point charge Q outside the conductor at point P. Find the electric potential at C. Find the electric potential at C. Electric potential at A. Electric potential at A due to induced charges. ये तो क्लास में किया हुआ. At C will be, this is C, right? Center C. At C, potential will be, you have kept Q here, right? KQ by PC. KQ by PC. Right? Due to induced charge, K integral dq induced by capital R. This will be 0. Anything else? There is nothing else. Right? That is the first bit. Second bit is asking electric potential at A is same as that of C.
Yes, sir. Same as the potential on
There is no
surface.
charge. Even if it had, it will not. So all throughout field here and here is 0. So potential at C, this was C, right? Will be equal to the potential at A. Absolutely no issue. Right? Now this potential at A will be potential due to Q plus potential due to induced charge. You know the value of this. You are asking me due to induced charge. You know the potential due to Q. KQ by PC.
Sir, can you explain why you equated?
Potential at A. What is the third question asked? What is the potential at A due to induced charges on the conductor? Q induced. So potential at A is because of this and this.
Yes.
Potential at A is equal to potential at C. Potential at A is equal to potential at C because there is no charge inside the cavity. So field is 0 all throughout. If field is 0,
Okay, sir.
potential will be the same at A and C.
Equipotential, yes.
Now third bit is asking potential at A due to induced charge. If you know the net potential at A is how much KQ by PC. KQ by PC. It will be because of Q and induced charge. You are asking me potential due to this. You can calculate potential due to Q. You know the potential due to Q at A. How much is that? That will be KQ by P. So will I get the potential due to QC?
Sir, inside the cavity, will the potential still be KQ by PC?
Inside the cavity, anywhere it will be the same. Potential here, potential here, potential here, potential here, potential here will be the same because the field is zero everywhere inside.
Yes, sir.
Inside the cavity, when there is no charge, field is zero.
Ha.
Now the next question you should be able to do. It's based on the same lines.
हाँ सर हो जाएगा.
अब ट्राई करो होगा.
हाँ सर हो गया वो.
Sudden.
Hey, listen. HCV and booklet I'll take later. One of these days I'm taking evening doubt picture for flagship 1 and 2. I'll send you people the link as
Okay
So
sir.
discussion
HCV
of
and booklet ka. HCV and booklet ka. Booklet electrostatics. Finish booklet as well. Keep that ready somewhere on Wednesday or Thursday evening when I'm taking the doubt lectures. Send you people the link. Clear?
Yes sir.
सर MT में कितना इलेक्ट्रोस्टैटिक्स आ रहा है? All of it?
Gauss law तक तो गारंटी आएगा.
Okay sir.
Gauss law flux. तो गॉस लॉ का फर्स्ट असाइनमेंट है, वहां तक तो गारंटी आएगा. ये जो ग्राउंडिंग ऑफ स्फीयर्स में एक दो क्वेश्चंस दिया हुआ है. ट्यूसडे आई हैव ए 6 hours लेक्चर इन दादर विद वन ऑफ द बैच. इफ आई कैन कम टिल देयर वो ग्राउंडिंग का क्वेश्चन रखेंगे, वरना वो एक क्वेश्चन निकालेंगे. सो गॉस लॉ तक तो गारंटी आएगी.
Okay sir.
चलो, see you people in the next class. Good day. Bye. Thank
Thank you.
you.
bye sir,
Sir,
thank
thank
you.
you.